Of course, today we are finishing this particular chapter that we started earlier in the week. And of course, we're going to start a new chapter on Monday, which is going to be the last topic of the summer semester. So today, we're going to be focusing on multivariate joint distributions. And of course, in the outline, I'm actually going to have a review on bivariate normal density. Then I'm going to move into multinomial distribution. Then I'm going to talk about expectations of product covariance and correlation. Let's have a review on bivariate normal density. Okay, so bivariate normal density. Okay, so if I have x, y that follows bivariate normal density, I'm actually going to have mean of this, the standard deviation of that, and the correlation. Of course, f of xy is 1 over 2 pi sigma x sigma y 1 minus rho squared exp into negative 1 minus rho squared x minus mu s divided by this plus y minus mu y, okay, squared, okay, let me, because of the further it continues, so minus 2 rho, okay, sigma s sigma y, rho sigma s sigma y, 1, let me see, x minus mu x divided by this y minus mu y divided by that. So I think I can just simply put this guy here. Okay, so when you take a look at this, okay, this is a bivariate normal density. And let me tell you the situation whereby rho, which is a correlation equal to 0, okay, what you see here is just going to be f of x equal to f of s multiplied by f of y. And of course, f of s is 1 over square root of 2 pi this exponential raised to the power minus half this x minus mu s squared, okay? And similarly, f of y is 1 over square root of 2 pi sigma y. So ex of p, this y minus mu y all squared. Okay, so the moment the rho, which is a correlation between x and y equal to 0, we're actually going to have f of sy to be that, which is what we call independent. Okay, that is for independent. But let me tell you this. We can also have situation under which our rho is not going to be equal to 0. Okay, we want to derive this. Of course, we actually going to make use of this. If we want to derive this, we have to make use of this. But let me tell you this, just like what I gave you yesterday, we have a way out, because if I want to go through this, I'm actually going to use a rigorous calculus to be able to come out with that. So I can specify this, okay? I can specify this, okay, for x, and I specify this for y, just like what I did yesterday. So if I simplify this guy, and your z1 is x minus mu x over sigma squared. So here, x minus mu x over sigma squared plus sigma y, 1 minus rho squared z2 plus mu y. Okay, now if I want to derive any of these, the essence of looking for this is for us to be able to derive this and this that I call conditional means. But do you know, I can, just like what I did yesterday, I can just, if I want to find the expectation of y, if I want to find expectation of y given x equal to this, I'm just going to come here, take the expectation of both sides, and let me tell you, z1 and z2, the z1 follow normal distribution with this, and z2 also follow normal distribution with that. So in that situation, now the only random variable here is z2. So if I take the expectation of both sides, okay, I'm actually going to have this guy. I'm actually going to have this guy plus this, okay, this, okay, expected value of z2, okay, plus mu y. And if you want to go by this, so this guy, this implies expectation of z2 equal to 0, then variance of z2 equal to 1, because z2 is a standard normal random variable. So which means this guy is going to go to 1, okay? Now, 0, because expectation of z2 equal to 0. Now, this is going to be completely eliminated. So here, I'm actually having this. Now, if I start from here, mu y plus this. Okay. Now, this guy is what I call mu2 in the lecture note. Okay. Why, if you see mu1 in the lecture note, that is the mean of x. Okay. Now, this is a conditional of mean. Now, do you know from here? Please, I need you to pay attention. From here, I can write out this. And I want you to see the way I'm going to write it out. Okay? Based on this, I can actually write out this. But before writing out that, I just found the expectation, conditional expectation. Let me also, because if I want to write a normal density, okay, I need the mean and the variance. I need the mean and the variance. Okay, now here, this is the conditional mean. Then I also need the conditional variance. Go ahead.
Z2 was.
What Z2 was? Z1 and Z2 are standard random variable. They follow normal distribution with this.
Z2 is just like y minus mean y over variance.
Okay, that's a very good question. Z2 is only going to be this if we assume there's no connection between x, y is not related to x. But right now, based on what you just talked about, okay, Z2 is going to be written in a way that is going to have a connection with x. Does that make sense? Okay, okay, go ahead.
So you mean x and y are dependent, right?
Yeah, situation where, like here now, okay, I'm only going to have this if y is dependent on x.
Okay, so the rho is like the
Correlation. Yeah.
Oh, okay.
The correlate. If the moment, if rho equal to 0, what happened? This is going to be nullified. What do you think I have? Is that this guy is going to be equal to expected value of y, which we call unconditional mean. Does that make sense? So situation where this happen, then that implies independence. Does that make sense? Okay, now let's look at the variance. Okay, I want to find the variance of this. Okay, let me tell you, if I want to find the variance of this, the only random variable is z2. All of this is going to be 0 because they are constants. Okay, now this is going to be 0. I'm only going to have the variance of this guy. I'm only going to have v of sigma y, this, z2. Okay, because the variance of this is going to be 0. The variance of that will be 0. Now, right now, this is a constant. So I'm going to have sigma this, 1 minus rho squared, variance of z2. What is the variance of z2? 1. Okay, so this is going to be variance of y given this equal this. Let me tell you something. If this guy is 0, this is going to be equal to variance of y. Now that now please take a look at it. Now that I know this, and I know this, then I will be able to write. I can write the conditional function. Okay, now if I want to write the conditional function right now,